Hello, myself Shushovan Rai. Currently, I am working as an assistant professor in EC department of Swami Vivekananda Institute of Science and Technology. Today, I am going to discuss the generations of control signal in 8085 microprocessor and the instruction sets of 8085 microprocessor. So, in this slide, I am discussing how the control signal has been generated. So using these three kind of pins, IO slash ember, read and write, we can generate some control signals. So we can generate basically four kind of control signals: memory reads, memory write, IO read and IO writes. So whenever IO slash ember, which is called the input output or memory, whenever it is logic 1, that means entire operations could be IO related. Whenever it is 0, logic 0, that means the entire operations would be memory related. Read write pins both are low active pin. Whenever read or write both pin are 0, in that case it will be activated, otherwise it will be not activated. So that is why these are known as the active low signal. So if we follow this truth table, we can see that whenever we are applying 001 combinations, in that case MEMR whole word, that means memory read operations, will be happening. Whenever 010 this combination is applied, then memory write operations is happening, and for 101 input output read and 110 input output write operations be done by the processor. So why such kind of operation could be performed? Because all of you know that whenever IO slash ember pin is 0, in that case it will be memory related operations, otherwise it is input output related operation. So whenever we are applying 001, that means 001 IO slash ember is equal to 0, that means obviously it is memory related operations. So the control signals I have written over there, ME or the memory related operation, and read pin is 0, that means this is also active low pin. So entire operation is MEMR. So that means memory read operations could be performed by the processor, and write pin is 1, that means uh, this pin is active low pins. So whenever we are applying 1, so that means this is not activated. So in the next combination 010, so read pin is 1 and remaining two pins are 00, that means it will be memory write operations. And same thing is happening for next two combinations 101. Obviously 101 means IO pin is now activated, and parallelly the read pin also activated. So entire operations will be input output read IOR bar, and for 110 the entire operations will be input output write operations or IOW bar operations. So these are the several kind of instructions or command is given below for 8085 microprocessor. So I am discussing over few of instructions. So MOV, one of them is MOV, MVI, LXI, LDS, ST and so on. So MOV means MOV R1, R2 means R1 is the destination register and R2 obviously the source registers. So what does it mean? The content of register R2 is transferred to R1. So instead of R1 or R2, we can take any kind of arbitrary registers which are basically given in 8085 B, C, D, E, H, L and accumulator A. So next one is MVI R comma data means if we want to move immediate any content or any data in any arbitrary register R, in that case such kind of instructions will be used. Next one is LXI RP 16-bit data. So that means 16-bit immediate data are moved to the register pair RP. It may be HL pair, it may be BC pair, it may be DE pair. Next one is LD address. LD address means the content of the content of any address locations, any arbitrary address locations could be loaded in accumulator or could be moved into the accumulator. So if we take LDA 9000 hex, that means the content of 9000 hex will be loaded into the accumulator. Next one is STA address. This is the reverse of LDA address. So that means the content of accumulator is transferred to any arbitrary memory locations. Next one is ADDR, SUB. These are basically categorized under the arithmetical operations. So ADDR means if we have taken ADDB, so that means the content of register B will be added with the content of register A, which is known as the accumulator, and by default the result will be stored into the accumulator. And same thing is happening for SUBR. And next one is INR. INR instructions is basically used if we want to increment some values. In that case we will go through INR instruction. So INR means the content of register R is incremented by 1. Thank you.